All right. So far we have solved quadratic equations by factoring. That's the only way we've done it. So this is going to be another method of us solving quadratic equations, and that's by taking square roots. We also have other ways we're going to solve quadratic equations coming up, like the quadratic formula you might remember, also by completing the square. So we have other ways we're going to solve quadratic equations. We're probably going to have a test on solving quadratic equations algebraically sometime next week, probably toward the beginning of next week. Okay, so what we're going to do is we're going to split chapter 4 into two different parts. We're going to do the solving part, and then we're going to do the graphing part. Okay, so sometime early next week, we will have a test on solving quadratics algebraically. So today we're going to solve by square roots. And before we solve by square roots, we're going to do a little bit of a review of taking square roots. I have on the board over there a list of all the perfect squares, 1 through 20. And I have also included 25 squared and 30 squared because those are kind of common. We see those pop up from time to time. I'm not using one. So, because you cannot, when we simplify square roots, guys, you cannot type it in and get a decimal. We're going to simplify square roots the way you're supposed to simplify square roots. We're not typing them in and estimating with a decimal. We want exact answers, not decimal answers. So I will not accept decimal answers. Okay? Because we have got to learn to simplify these because there's so much more we've got to do with them. So let's just start with one like the square root of 20. And again, I'm not going to punch that in my calculator and get the decimal, even though the answer is 4 point something. Okay, I can estimate it, and I can do it in my head. Because I know the square root of 20 is somewhere between the square root of 16 and the square root of 25, right? The square root of 16 being 4 and the square root of 25 being 5. So if I want to simplify this radical, you've done this in Algebra 1. We spent a lot of time on it in Algebra 1. What you want to do is you want to find the largest square that goes into 20. Now, all my square numbers I have underlined in red on the board. So I'm looking at the numbers that are underlined in red. So 20 falls between these two. Which one is the largest? So 25 doesn't go into 20. So everything from here up will go into 20. So which number is the largest square that goes evenly into 20? 4. So what times 4 equals 20? 5. So you want to change radical 20 into radical 4 times 5. And what is the square root of 4? The square root. That means what multiplies times itself to get 4? 2. So after you take the square root of your square, you pull it to the outside. So that's 2. So that takes care of the square root of 4. You still have a 5 under the square root sign, and we call that a radical. So your simplified answer for square root of 20 is 2 radical 5. 2 radical 5. Okay? Okay, so that's how we want our answers. We don't want decimal answers. We want simplified radical answers. So, next one. Radical 18. Radical 18. So you want to try the largest square that goes into 18. Because 18 is not a perfect square. I'm going to get a decimal if I put that in my calculator, not a whole number. So what's the largest square do y'all think that goes into 18? 4 is not going into 18. 3 is not a square. The numbers that are underlined.
9.
16 goes into 18?
No.
9 goes into 18.
Oh my God.
Right? It's got to be a square. That means it has to be underlined, and it has to go into that number. Y'all, this is example 2. It gets a lot harder today. Focus. Okay? All right. So do y'all agree with me that 9 is the largest square that goes into 18? 9 times what equals 18? So this is square root of 9 times 2. What is the square root of 9? That means what squared equals 9? 3. Bring the 3 out. and you leave it radical 2. So 3 radical 2 is radical 18 squared. Okay, radical 32. Now, guys, there's a couple of squares that goes into 32. You want the largest one. 16 is the largest one. 4 goes into it also, but 4 is not going to get you a simplified answer. So the way I do it is I work the chart backwards. 32 falls between these two numbers. Does 25 go into it? No. Does 16 go into it? Yes, 2 times. Okay. So if you're not sure which one is the one you use, I like to work my chart. So it might be wise for you guys after the lesson for y'all to copy down that chart on a piece of paper. So this is 16 times 2. And what is the square root of 16? Pull it to the outside, and that leaves a 2 on the inside, so it's 4 radical 2. Any questions? Okay, so those are all just simplifying the little singular ones. Now let's see if we multiply something. Now the rule for multiplying with radicals is you multiply outsides times outsides and insides times insides. Both of these are on the inside, so you just multiply the two inside numbers. So what is 2 times 45? 90. So we're going to have this as radical 90. And then we just follow suit with what we've been doing. We simplify that radical. Okay? So we want to find the largest square number that goes into 90. So what do y'all think is the largest square that goes into 90? 9 is the largest square that goes into 90. So I'm going to make it radical 9 times 10. Square root of 9 is what? So it's 3 radical 10. There's no squares that go into 10. Yes. You can simplify a radical as long as there's a square that goes into that number. There's no squares besides 1 that goes into 10. Because 9 don't go into it, 4 don't go into it, 1's the only one that does. So that's how you know you're simplified, is if you're radical at the end, if it doesn't have any other squares that go into it. All right, example E. We're going to do fractions. Okay. So if you have a square root sign over an entire fraction, what you're going to do is you're going to give the radical to both the numerator and the denominator. You're going to give a radical sign to both. Can we take the square root of 25 and get a whole number? Yeah, it's 5. So we just write equals 5. And what's the square root of 36? 6. So that just simplified to 5 over 6. So once you take the square root of something that's a perfect square, both of these numbers are perfect squares, you should not have any radicals left. Okay? Because the square root of a perfect square is a whole number. Is that okay with everybody? Okay. Oh, this next one's not bad. Example F. Another fraction, square root of 7 over 16. So what do we do first if it's a fraction? Remember? We give them both their own square root symbol. So we're going to say radical 7 over radical 16. And are there, 7 is not a perfect square, is it? No, it's prime. Are there any squares that go into 7 besides 1? 4 doesn't go into 7, does it? So nothing does. So that one will not simplify. So if it will not simplify, you leave it alone. We're just going to leave radical 7 alone. And then the square root of 16 is what? 4. Now this is okay to leave as an answer. It still has a radical in it in the fraction, but as long as the denominator comes out to be a whole number with no radicals, we're good to leave it like that. You cannot leave a radical in a denominator. Okay? So this is our, write that down. You cannot leave a radical in a denominator. You can have them in the numerators, but you cannot have them in the denominator. I'm making sure I spelled that correctly. So, if you take the square root of something in the denominator, it needs to come out to be a solid whole number. You need to be taking the square root of a perfect square. That doesn't always happen, right? So, since it doesn't always happen, we have to do something called rationalizing the denominator. So now we're going to practice rationalizing denominators. Again, this is something that we should have done in Algebra 1. You did. You did. Your algebra woman taught you this. Well, she did. She remembers. Not everybody gets to it, but I know it's something that I make sure I get to every year. So if you had me for Algebra 1, you had it. All right. So, say we have a fraction. We're taking a square, not g equals, it's g example. Say we have the square root of a fraction 5/2. And we have to simplify that. So we give everything a radical. So that is radical 5 over radical 2. Will radical 5 simplify? No, there's no squares that go into 5. What about radical 2? No, but this little rule right here says I'm not finished. Because I cannot leave the answer radical 5 over radical 2 because it's mathematically illegal to leave a radical in a denominator. It's just not simplified to do that. Okay? So what we have to do to fix a radical in a denominator is rationalize it. And the way we rationalize it is we take that denominator and we make a fraction out of it, putting that number over itself. So we're going to multiply by radical 2 over radical 2. What does any number divided by itself equal? 1. So I'm multiplying that fraction times 1. So mathematically, I'm not changing the value of it, but I'm changing the way it looks. Okay? So multiplying fractions, don't we go straight across? Numerator, numerator, denominator, denominator. That's what I'm going to do. So radical 5 times radical 2 equals radical what? 10. And y'all can go ahead and tell me, does radical 10 simplify? No, there's no squares that go into 10. And what is radical 2 times radical 2? Radical 4. And what's the square root of 4 equal? So there we go. Just drag your radical 10 over. And there's your answer. You can leave a number in the denominator, but you can't leave a radical. Okay? So that's why we rationalize denominators, is to make it come out to be a whole number without a radical on the bottom. So just take whatever original denominator you have and make it a fraction, dividing it by itself, and then multiply across. And then you should have a square. After you multiply something times itself, you should have a square. It comes out to be a whole number. Okay? Let's practice another one like that. This one is the square root of 2 over 15. Whoops. So what do we do first when we take the square root of a fraction? Give them each their own radical. Now everybody can do this step, right? So if this was a quiz, we're not going to leave this blank. We can at least give me this step and get a few points, right? Right? No leavey blankies in here. Now, can we simplify radical 2? Are there any squares that go into 2 besides 1? No, 2's prime. Are there any squares that go into 15 besides 1? What square? I don't think so, because 9 don't go into it, 4 don't go into it, so that's all I got. So we're going to rationalize, which means I'm going to multiply by radical 15 over radical 15. So whatever the denominator is, you multiply by that. Okay? Radical 30 over radical 225. Very good. Does radical 30 simplify? Are there any squares that go into 30? Well, try it out. 25 go into 30?
No.
Does 16 go into 30?
No.
Does 9 go into 30?
No.
Does 4 go into 30? No, there's no squares besides one that go into 30. So radical 30 is already simplified. That's one that you see a lot, so you might want to memorize that. Radical 30 won't simplify anymore. And what's the square root of 225? 15. And you leave it like that, and there's your answer. Now you can't, you're looking at that 30 and 15 thinking you can reduce that to 2, but you cannot reduce something in a radical with something not in a radical. So that is simplified already. Okay? I do want y'all to practice one of these on your own. So y'all try on your own paper, this one, radical 3 over 7. Simplify that. Rationalize that denominator. Bless you. If you think you got an answer, go ahead and check it with a neighbor. All right, what's the first thing you do when you simplify a radical with a fraction in it? Give them both their own radical. So radical 3 over radical 7. Does any of those simplify? No. So we can't simplify radical 7. I mean, we can't leave a radical in the denominator. So what do we multiply by? Radical 7 over radical 7. Multiply across. Radical 21 over radical 49. Does radical 21 simplify? Nope, so you can leave it the same. There's no squares that go into that. Square root of 49 is 7. And there's your answer. Raise your hand if you got radical 21 over 7. Any questions? All right. The next one, we're going to use something called a conjugate. And yes, I taught this one in Algebra 1 too. Okay, conjugate, that's not my fault. I taught it. Remember the word? Did I spell it right? Conjugate. Yes, I did. All right. If you have a fraction, what example is this? J? Or is it I? It's I. All right. If you have a fraction with a radical in the denominator, but it has a plus or a minus with it, that's when you're going to use something called the conjugate. So this isn't just radical 2 in the denominator that we can't leave it there. We have 7 plus radical 2. So that's when you add or subtract a radical in a denominator. And I'm writing this down first so we have a hint. Add or subtract in the denominator. Okay. So, we're going to use something called the conjugate. And just like we multiplied a fraction times something on top and bottom, we're going to multiply the conjugate of 7 plus radical 2 on top and bottom. Now, 7 plus radical 2's conjugate is the same thing, except for it's going to have the opposite sign in the middle. So it's kind of like difference of squares. So it's 7. Okay. So we multiply by the conjugate, and this conjugate is to take that denominator and you change the sign in the middle. So this is basically like a difference of squares. And what multiplying times the conjugate does, we're going to go ahead and do the denominator first, is it should get us down to where we only have a number with no radicals in the denominator. Okay? So in the denominator, you're going to take 7 and square it. You're going to put a minus in the middle. And you're going to take radical 2 and you're going to square it. Okay? What is 7 squared, y'all? 49. And y'all, a radical and a square cancel each other out, so that's just minus 2. So you square and the radical cancel each other out, and you're left with the inside. And what is 49 minus 2? And that is my new denominator. So a conjugate gets you where you only have a number in the denominator. You square the first term, square the last term, subtract them. Squares and radicals cancel out. You get a number. Okay? The top you're going to distribute. Okay? So 3 times 7 is what? 21. And when you multiply something on the outside that doesn't have a radical with something that does have a radical, you just kind of stick, it's like saying 3 times x is 3x. So it's 3 times negative radical 2 is negative 3 radical 2. And this is your answer. Okay. Let's practice one more of these. Four over 5 minus radical 2. We just did a radical 2. Let's make this one a radical 3. Make it slightly more interesting because we just did a radical 2. Okay, so since you have a plus or a minus in the denominator with the radical, you're going to use the conjugate. So what is the conjugate of 5 minus radical 3, do you think? Good. So you're going to multiply by 5 over 5 plus radical 3. And you can do the numerator first if you want to. You just distribute it. I like to do the denominator first. So you're going to take the 5, square it. Minus always a minus. And then radical 3, square it. First term squared minus last term squared. And what is 5 squared? 25. And the square and the radical cancel out, and that leaves you with 3 underneath. And what is 25 minus 3? 42. Feeling it. Right. So that's your new denominator. Any questions on the conjugate part, the denominator? So you're just basically finding a way to cancel out a radical to get you a number. And on top, you're going to distribute. What's 4 times 5? 20. Plus, what's 4 times radical 3? 4 radical. No, you can't combine them. You just stick them in front of each other. It's like 4 times x. 4 radical 3. And then there's your answer. So that's what you do if you have a plus or a minus in the denominator with your problems. You won't have very many of those to practice with. Now, we have done all of this. This is all review. We did all of this in Algebra 1. If you had me, you for sure did. If not, it's possible that you did. But this is all practice simplifying radicals so that we can do our next thing that we're really supposed to be doing in this chapter, and that's solving using radicals. So solving a quadratic equation using square roots. So this is really what we've practiced all of that for. That was all the build-up. Nope, it's the same section. All right, example K. Let's do an easy one. 10x squared equals 80. X squared equals 80. So we're going to have a quadratic equation. That means an equation with an x squared in it. Because remember, equations that have x squareds in them are called quadratics. Okay? We're going to have a quadratic equation, and we're going to have to solve them. Okay? So first you want to get the square by itself on this one. So how do you think we're going to get our x by itself?
Times by 10.
Divide both sides by 10. Very good. So that leaves me x squared equals 8. Now let's talk about inverse operations for a second. The inverse operation is an operation that mathematically undoes another operation, right? So what undoes multiplication? We just did it. Division. What undoes addition? And vice versa, right? Do y'all know what undoes a square? Taking a square root, which is a radical, right? So if we want to get rid of the x squared and solve it just for x, which is what we want to do, we're going to take the square root of both sides. So that's what you got to do next. Square root, square root. So the square and the square root cancel each other out, and that's how you're left with just x. Okay? But when we take the square root of something, we got to consider it being positive or negative, because the square root of 8 could be a negative something or a positive. Because think about 36. 36. What multiplies to get 36? 6 times 6. But also, negative 6 times negative 6 also multiplies to get 36, right? So you can consider them being both positive or both negative. So to take account for it could be two different things, positive or negative, you need to put plus or minus the square root of 8. Plus or minus the square root of 8. That means the negative or the positive. Can we simplify radical 8 though? Is there a square that goes into 8? Huh? 4. So that's the last thing we have to do here is simplify it. That's 4 times 2. And what is the square root of 4? 2. Pull it to the outside. So x equals plus or minus 2 radical 2. Final answer. So negative 2 radical 2 and positive radical 2. Positive 2 radical 2 makes 10x squared equal to 80. So take the square root of both sides to get rid of the x. Put your plus and minus. Simplify your radicals. Okay? Let's do another one. JKL. Let's do this one. 2x squared minus 15 equals 65. So just like what we'd do if it was a regular x and not an x squared, we want to get the x by itself, okay? We want to get x by itself. So we're going to, good job. Add 15 on both sides. There's a good start. I'm going to get the same darn thing. It's going to be 80 again. Let's make that 25. Sorry. That's what I get for not working out my problems ahead of time. Yeah, let's do 25. So that gets me 2x squared equals what?
90.
90. And then what?
Divide that to
Divide both sides by 2.
45.
X squared equals 45. That's a good one. All right, what do we do when we get x squared by itself?
You gotta put them in the frame to square root.
Take the square root of both sides.
And on the x squared, you're gonna calculate out.
So x equals plus or minus square root of 45. And then we simplify the radical. So what's the largest square that goes into 45? 9. So that's 9 times 5. And that's plus or minus, what's the square root of 9?
3.
So 3 radical 5. Sure. Yes. Y'all are on YouTube, by the way. We're recording our lesson. That's what you get when you enter at my class. You never know. Ha ha. Yep. All right. So that's example L. Example M. Let's do this one. 1/5 parentheses x plus 3 squared equals 7. This one looks a little different
How you do it?
because it's got, we're not going to distribute. That's actually going to make our life harder. So what can I do besides distributing to start working on getting that x by itself? Very good. To get rid of 1/5, you can multiply both sides by its reciprocal, which is 5. And that actually is going to help us a lot. So we're going to keep our parentheses x plus 3 squared equals what is 7 times 5? 35. Okay. So now I can't get rid of the x just yet because I got that square and I got that parentheses. So when you get, if you have parentheses like this, go ahead and take the square root and get rid of your square. Okay? So we're going to take the square root of both sides. Cancel, cancel. So that leaves us with just x plus 3 equals, are there any squares that go into 35? No, so that's not going to simplify at all, is it? So let's leave this plus or minus radical 35. And how are we going to get the x by itself now?
Subtract 3.
Just subtract 3. So what we're going to do is we're going to leave our answer x equals negative 3 plus and minus the square root of 35. Okay. So I know we're so used to getting answers like x equals 5 and x equals negative 1/2. That's not going to happen. Okay? Our answers are probably going to have radicals in them. All right? Do I need to do another one like this? All right, I'm trying to find one that's not crazy. Another one with a fraction like this? Okay. 1/3 parentheses x minus 4 equals 11. Oh, that's supposed to be a square. I forgot the square. All right. So what do you think we're going to do first? Multiply both sides by 3. Those cancel. So parentheses x minus 4 squared equals what? 33. Now everything's tied up in parentheses with a square. So what do I do to get rid of the square? Square root. And remember what you do to one side, you got to do to both sides. So we got radical 33 over there. Are there any squares that go into 33? No. So leave it plus or minus radical 33. Stick it in front.
plus or minus 33.
Radical 33. There's your answer. So it's really not that bad. I'm trying to see. I think I might want to do one more. Can we do one more?
Yes, ma'am.
Just to make sure I've showed you everything that's on the homework. I don't want to leave y'all hanging on something I hadn't showed you. I showed you something similar. Whatever. Not if you don't get done in class, it is. All right. So we want to solve this one for x. So I think we had an example similar to this one. So I think we should be able to get through this one.
Minus 5 on both sides.
Good. 3x squared equals what? 36. Then what do I do?
What's the count? Divide on both sides.
Divide by 3.
3 on both sides.
Yeah. If you don't have parentheses, you want to get your x squared by itself first. So x squared equals what? 12. And then what do you do to get rid of the square? Square root. That cancels. Does radical 12 simplify? Don't forget your plus and minus. What goes into 12 is the square? 3 and fix it up. X equals 34. Any questions? All right, so here's our practice. The official time is 2:24, so you've got 35 full minutes left of class to get this done, or get a good start on it anyway. Page 269. I want you to do 3 through 17, just the odd ones. And yes, those numbers. And then 22 through 31, I want you to do all of those. And we'll stop recording now. Goodbye.